morning class. For today's small class, we'll be learning about cyclones. In our last class, we have already started with cyclones, and I also told you how cyclones and jet stream play a crucial role for your CDS and NDA exams. Likewise, in NDA and CDS exam, geography has three parts basically. It's your Indian geography, your physical geography, and your world geography. In Indian geography, they will basically ask you about the Himalayas, the drainage system, the plateaus, the mountains, the plains, and the islands, right? So they will ask you to arrange the islands from north to south, from south to north, or which is the highest peak. So that kinds of question. Then we move on to physical geography. In physical geography, they will be asking you about wind patterns, like we're starting now. They will be asking you about the cyclones, why cyclones occur, how cyclones occur, the reasons for their formation, these kinds of questions. They will also ask you about volcanoes. Where do we find the most number of volcanoes? What are volcanoes, or what are the different types of volcanoes? Why do they occur? Where do they occur? How do they occur? These kinds of questions can be asked. Finally, we come on to world geography. In world geography, they will basically ask you about the different tides, ocean currents, warm currents, cold currents, how the different factors are affecting world geography, the topography. So these kinds of questions can be asked, right? So let's start with today's class. Right. For today's class, we'll be learning about the different names of cyclones. So cyclones have different names in the various regions. Cyclones, the name of cyclone in Pacific is different from the name in Asia Pacific. The name will be different in Australia. The name will be different in Philippines, in Indian Ocean, or in India. The name will be different. So we'll be learning about that. Then we will be learning about the different stages of a cyclone, from its early stage to its formation stage to its mature stage. So why cyclones occur, how do they occur, or what are they doing, and then finally what happens in the last stage. So we'll be covering these topics in today's class. So let us. So first we have what is the origin and development of tropical cyclones. So origin. So tropical cyclones, of course, we all know they form over warm waters, very large water bodies. They need strong local updraft of warm air. They will need Coriolis force and multiple thunderstorms form to create an low pressure system. So these are the important points. So basically we need warm water, Coriolis force, and multiple thunderstorms, right? Then we come on to the early stage. So what happens in early stage? So basically in early stage, the warm moist air, it rises, right? It rises, then the heat fuels more rising and creates low pressure. Then of course there is the Coriolis force. Coriolis force creates the whirling effect of cyclones, and then we get the eye of a cyclone. Eye of the cyclone has clear weather or calm weather. So these are the important points here. I'll be marking it here. So basically we have the origin. So we have the origin. So tropical cyclones form over warm tropical oceans in late summer. So it also needs Coriolis force. Multiple thunderstorms merge to create an intense low pressure system. Then we have the early stage. In early stage, warm moist air rises, cools and condenses, releasing heat. This heat fuels further rising and creates a low pressure area. Then we need Coriolis force, which deflects the air. And finally, the center of the vortex becomes the eye. It is a calm region surrounded by wall, right? So this is the important point. So we have the origin and the early stage. So this is a diagram to better understand it. So here we can see how tropical storms are formed. So firstly, water evaporates from the ocean surface and comes into contact with cold air, thus forming clouds. A column of low pressure develops at the center. Winds form around the column. Lastly, we have as pressure in the central column weakens, the speed of the wind around it increases, right? So we learned about the origin, we learned about the early stage. Now we'll be learning about the mature stage and finally the structure of a tropical cyclone. So mature stage. So what happens in mature stage? In mature stage, spiraling winds create multiple convections, right? Then we find rain bands. So what are rain bands? The rain bands are nothing but just the clouds which form rain, right? And then we have calm regions between the rain bands. So between every rain band, it is a very calm region. So this is an important point you have to remember. Rain bands are rainfall, as the name suggests, and between rain bands, it is a calm region. Cloud cover is densest at the center and decreases towards the periphery. Then we have structure of a tropical cyclone. So we have the eye. So calm center with light winds and clear skies, lowest surface pressure, and warmest temperature aloft. Then we have the eye wall. So it surrounds the eye. It is the area of most intense convection and highest winds. Then we have spiral bands. It is the long, narrow rain bands spiraling towards the center, areas of maximum low-level convergence and upper level. Thus, in metro stage, we remember we find spiraling winds, we find rain bands. Rain bands are nothing but they are the areas where rainfall occurs. And then we have to remember in rain bands, between rain bands, it is a clear and calm weather. So now we will learn about the vertical structure of a cyclone. So what is the vertical structure? At the top we have inflow layer, right? In inflow layer, it drives the storm by drawing in warm moist air, right? So the inflow layer, moist air comes up, it turns and whirls the cyclone. We have the mid layer. It is where the main whirling or circulation occurs of a cyclone. And finally, we have the outflow layer. In outflow layer, the air flows outward in anticyclonic pattern, right? In inflow, warm air rises. In mid layer, circulation happens. In outflow layer, air flows outward in anticyclonic pattern. Then we have the key points. So the key points are cyclones are fueled by warm ocean water and moisture. They dissipate when they move over land and lose their moisture. The eye is a calm region. Rain bands are area of heavy rainfall, and Coriolis force plays a key role in the cyclone's rotation. Now, as I had said before, as I said before, we will be learning about the different names of cyclones. So, firstly, we have Southeast Caribbean. It is known as hurricanes, right? Then we have Philippines, Eastern China, and Japan. It is known as typhoons here. Then we have Bay of Bengal and Arabian Sea. It is known as cyclones. We have Southeast African coast and Madagascar, Mauritius Islands. It is known as cyclones. Finally, we have Northwest Australia, which is known as Willy Willies. Then we have the characteristic of tropical cyclone. So the size and shape, it's basically symmetrical elliptical shape. It is a compact size ranging from 80 km near center to 1500 km in diameter. The range is from 80 to 1500 kilometers. So with this, we have come to the end of today's short lecture. In our next class, we'll be moving on to part 3 of cyclones, and finally we'll be moving on to jet stream. So thank you class. Jai Hind.